This question is asking us to write the equilibrium constant expression for Kc and Kp for this formula right here. Next, calculate the Kc, and then they give us moles per liter value of the components of the equation. So let's begin by writing the equilibrium constant expression. They're not too difficult. Basically, how you're going to write it is you're going to be doing the product divided by the reactants, and then whatever the coefficient is in front of the reactant or product, you're going to put it to the whatever power. So I guess as I write this will probably make more sense. So for Kc, we're going to be doing NH3. One more note, so when you're doing any sort of equilibrium constant, you have to be dealing with either, or you really just have to deal with gases and aqueous solutions. Any liquids or solids would not be included in your Kc expression or your Kp expression. So for example, if, I don't know, NH3 was a liquid, well, who knows, whatever. And if NH3 was a liquid, then you would not include it in your Kc expression. But in this case, since NH3 is a gas, you can include it along with H2 and N2 because they're all gases. So anyway, so the product NH3 over the reactants. So I'll start with N2. And as you can see, its coefficient is a half, so you raise it to the half power. And then we do H2. And we'll raise that to the 3 divided by 2. And that would be your Kc expression. A thing to note is in this Kc expression, our values are in brackets. When we do the Kp next, those are going to actually be in parentheses. So Kc and Kp are very similar. Again, you can only include gases or aqueous within the problem. You cannot include liquids or solids. And again, you would raise it to the power of the coefficient. The difference is, though, that you're going to be using parentheses and you're going to be denoting all of your concentrations with a P. So we'll start again with our product. And again, look, parentheses. P NH3, and you're going to divide it by the reactants. And again, for N2, you're going to have it to the half power, and remember to put your P in front. And lastly, H2. Oops, I forgot the P. I'm doing my own wrong. Doing this wrong. Okay. That is correct. All right, next is asking you to calculate the Kc, and they give you your concentrations there, which is great. Makes your life so much easier. And we have our formula rewritten, so now really all you have to do is plug in. Pretty simple. So we'll take our Kc, and we'll plug in our values. So we know NH3, our products are on top. And they give us our value, 0.45. And then we're going to divide by our reactants. So N2 is 0.76. And don't forget, you have a power of a half. And then you're going to put in H2, which is 1.31. Again, don't forget the power. And again, I'm doing everything in brackets because it's Kc. And you plug that into your calculator, pretty simple math. And you're going to get a Kc of 0.34. And that would be your answer.